Hello, everybody. My name is Fernando. I'm one of the instructors here at CodeUp in Dallas. So let me introduce you to my coworker, Douglas.
Hey. So my name is Douglas, and I am also one of the instructors here at our Dallas campus. Together, well, I was gonna say, I actually bring about 18 years of software development experience, and some of the stuff that we're going to go over with you today is stuff that I've actually experienced in the battlefield, on the ground, writing code day to day with someone next to me. So it's cool to actually be able to show you all how this works in a presentation like this.
Yeah, so a little bit of our background. I'm originally from Mexico, and I also have some experience working in different companies in two different countries, I guess. And one of the things that we want to show you is instead of focusing on just one particular language or specific technique, is going to be how or what are the expectations after a trained in this job? Like, what is a software developer day by day looks like? So today we're going to show you that workflow, the things that we have seen in the field, and trying to combine it and see how we solve problems together and face problems live as well. Like maybe we're gonna find something interesting to fix or something like that.
Right.
So that's a little bit of the background. I feel like Dimitri did a great introduction of what programming is gonna look like and what pair programming is gonna be our main focus today. One of the things that we wanna explain is why we're gonna use a specific language. Today we're gonna be using JavaScript as our main language. Because he introduced less confusion about like how the language works. Just keep in mind that we're gonna do a lot, or we're gonna make a lot of assumptions about like, we're not gonna have enough time to explain every single piece of the syntax. It's more about like a demo of how programming looks like, how working with pairs look like, and how testing your code is gonna look like. But we're gonna have soon a link for a crash course on JavaScript. If you are more interested and really excited about after this one, you can actually go back and see how JavaScript crash course can help me to understand more of the syntax that we're going to use today.
Yes.
So I think we can start with explain a little bit of the pair programming. One of the things that we like to encourage and to teach while you're in CodeUp is collaboration. There's a misconception about this career about software developers not being a team player or a team job where you're just like coding in a basement or something like that, all the lights off, stuff like that. So that is not actually true like in most of the cases.
But I do have my hoodie.
You do have a hoodie. I do not have, so we want some balance in here. So one of the things we want to make sure that you could understand is like how we can actually collaborate, right? You're actually writing code. And while you're writing code, I feel like there's a lot of ideas floating around, and having somebody next to you to question the ideas you're trying to implement, keep asking questions about how we can implement different things. I feel like it's really helpful in this career. So that's a little bit of what we want to show you in pair programming. Before we dig in, I feel like we need to explain you a little bit of what the dynamic is going to look like. So when you're doing pair programming, we're going to assume two different roles. The first one is the driver. That basically is the programmer that is typing the code into the computer, and there's going to be the navigator. The navigator is going to be the one that is actually watching the other programmer typing the code, making questions, or helping the other programmer to see like, hey, you have a typo here, you forgot to close the statement, or several symbols that we need to like put sentences that look like English, and it could be translated into machines so that we can send those sentences basically.
Sure, and another way of looking at it is just like when you like board a plane and fly a plane, you've got a pilot and a co-pilot.
Exactly.
So I'm depending on which role we choose to take, you'll see us switching around a bit between the two. I will go to being the driver or the pilot in this analogy, and or depending on, Fernando will be the pilot and I'll be the co-pilot. It'll just switch around, and we'll tell you when we're switching around.
Yeah, the reason we want to switch is because we want to have the opportunity to write code at the same level, and also to be able to provide ideas or question what we're doing, if there's a better way to do it. Since programmers come with different backgrounds as well and different types of experience, it's always a great idea to pair with people that are not even in your same level. Because most of the people get afraid of that, like how can I get to the level of this person? If they're a senior developer, a junior developer, that's actually how we learn, right? Especially when you learn new languages. I feel like there's a lot of syntax that we have to learn on the process that it's impossible to know everything. So I feel like we can always learn from each other. So that's what we want to encourage today and show it to you. So again, we're going to be switching roles, maybe more often than it should be. More likely, you will see it in the field switching every 30 minutes or so. Since we don't have a lot of time, we might be switching based on features. Like whenever we feel that we finished something, we're going to do a switch. It doesn't happen that often because it will be like disrupted, but just to give you an idea how it might look like on a smaller scale, if that makes sense. That's about like how the workflow is going to look like. Now, the last part that I want to touch is Dimitri was mentioning, we are going to apply a little bit of TDD. That is commonly known as test-driven development.
Yeah.
So the reason we want to show you this is because it's a brand new technique and programming skill that we included in our curriculum. So our students are going to be able to understand the basic concepts of how to implement code and test it before we actually write any production code. That means any code that is actually running and giving you the results that you wanted in the first place. So that way you can think about all different ways to test your code, break your code before there's actually code that is running. So that way you don't have to worry about like, oh, I think I'm finished, and then I go to sleep and I'm like, oh, I'm nervous. I feel like I forgot X, Y, and Z or something like that. And I feel like no matter what the level you are in a developer, everybody feels this way, right? So in order for us to reduce the amount of anxiety or something like that that we get by not finishing something and not feeling comfortable with it, creating tests for that code is going to be a great idea. So the TDD is going to be focused on create the test first, write the code later, and see if the expectations are matching your results. So that's going to be the things that we want to show you. Again, just as a reminder, we don't have enough time to explain the whole syntax, but what you can get the most from this webinar is going to be how a workflow, how a day of the developer might look like in 2020, if that makes sense.
Right. So enough talking. Let's get into the code.
Okay, so let's share a screen with our friends, so that way that we can show them how we can start to implement these features. I feel like it's the first one. No. Cool. So for the first iterations, I feel like we are gonna start with these roles. I'm gonna be the driver. You're gonna be the navigator. Are you okay with that?
Yes.
Cool. So I have a couple of ideas that I wanted to test and write a couple of functions for software. And I believe the first functionality that I can think of that is really, really simple and everybody can relate to is adding two numbers between each other. So in theory, I basically just want to have a basic math operation in my code, right? In JavaScript, one thing that can help me to see if I'm doing things right is if I console log the results. Console log, think about it as it's just like printing the values, right? So right now I cannot see what's going on in here. If you take a look at my screen, you can actually see that I'm just typing a bunch of numbers in an operation, but I don't really get the results. Now, this operation is simple enough for me to make the operation in my head and assume that I'm going to get the results because I know that 1 + 1 is going to be 2. But again, my script inside of this computer is not going to do anything until I put the right syntax. So let's play with it a little bit. I'm going to open my console, which is what JavaScript is going to be able to run and tell me if my code is running or not. You're actually going to see a small error in here that basically is telling me like nothing that you're writing is making sense. And I mean, that's fine. I just want to make a representation of what's going on in here. So let's make this code in something that makes sense. By the way, in JavaScript, you can create comments by just putting double slashes in here. Now, the next part that I want to do is, as I was telling you, I feel like it's important for us to see what the result is. So one of the things that I want to show you is how to print values. So let's type a little bit of syntax in here so that way we can console log a number. Now, inside of the console log, you will see in this parentheses that it can take values. So what happens if I just actually put the operation inside of it? You will notice a small change in my console. In the console, you will see that now we get the result, and is this result that I was expecting in the first place. Now, This is just assuming that this is gonna be helpful if this operation is always the same numbers. But I can think about many ways to make this break, in many ways to make this more dynamic. Right now, it only is gonna work for these two numbers. Now, for the next part, I feel like we are gonna do this operation a lot of times. So one of the things that I was thinking is, if I'm gonna reuse and use this a lot, I think it's gonna be helpful to put this inside of a function so that way I can keep calling it over and over and just change the parameters on the other side. So one of the things that I was thinking is put the result, since that's the thing that I already know. I know that I'm expecting a number 2. And then use an operator that can tell me if I can find a value that is equals to the expectation that I'm looking for. Now, applying TDD, what I'm doing in here is thinking about all the tests that I want to run before I even have the implementation of the code. So I'm just going to assume that I do have a function called add, but that is not true at all. You will see what's going to happen when I'm doing this. You're going to see that I have an error on the bottom that says the add function is not being defined. That means that it doesn't exist. So one of the things that I'm thinking is just think about all the cases and scenarios that I want to think of. And this is probably the most positive way of thinking. This is the most positive way that I can think. Positive numbers, the most simple addition between two numbers that I can think of, but still I have an error, and it's because I haven't grabbed enough code in here.
Right.
So I'm going to give you an exclusive preview to our curriculum today. So I'm going to show you the document that we use during our course, because I want to show you a diagram that is going to help you to understand what we're doing right now and to try to justify it, because I'm just getting a bunch of errors. So you might think like, why are you coding like that? It seems like you don't know what you're doing, right? So let me show you something interesting. When we're applying TDD in our code, the first thing that we want to do is start by writing tests, and you know that you're going to be in the red zone. That means that you're going to make a lot of mistakes. You're going to get a bunch of errors because most of the code for your test is not finished yet. So maybe the syntax is not complete. Maybe the syntax is not going to be ready to go. So one of the things that you want to do is make sure that you just thinking about what are the pieces that you want to play with? What are the pieces that you want to test? And think about all the positive ways to make it work. And then let's go negative. This is going to be the first time that I'm going to ask you, be a negative person a little bit, right? And let's think about all the cases when everything could go wrong. So right now we're still in the red zone. We want to make sure that our test fail, which is actually true, but we want to get here where the test has enough code to make it pass. So what I'm thinking is going back to my code, one of the things that I can do is fix this problem.
I have a question.
Yeah.
Why is it smart to have a failing test first?
Oh, it's a smart idea to have a failing test, because that way when it passes the test, you can be sure that it passes when you know when it's going to break and you know when it's not going to break. So basically you cover both sides of the coin, right? Not just one, because you just, as a programmer, most likely you're going to focus on the positive side of things. And we never thought about like, well, what about these other 5 cases? What about when everything goes wrong, right? A simple example for that is a bank account, right? When you go shopping or something like that, you're just thinking about the positive side of things. It's like, I have enough money to buy this, right? So you're gonna give it a try, then you're gonna run this process through a function that gets your money out of your account. And there's gonna be a point where the positive side is not positive anymore. You no longer have enough money, and that's going to be an exception. What happens if your bank account goes -1, right? Can we still have a negative impact in your bank account and stuff like that, right? So we want to make sure that we cover both of those sides, if that makes sense.
Makes sense.
Does that answer your question?
Yes.
Cool. So one of the things that I want to do here is like, it seems like we have a lot of problems to solve. The first one, we can focus on the error. Most of the programming languages that you're going to deal with in this career are going to give you errors. Most likely the errors are trying to communicate what the problem is. So reading the errors is always a great idea. And I feel like I found my problem. The add is not being defined. So that means that the function that I'm trying to use does not exist automatically. It doesn't come with JavaScript, right? It doesn't come with the language. I have to build my own function for this. So I'm gonna type some syntax to create the function. We use the same name that I was expecting to use on that function, and then put a little bit of syntax in here so that we can make it happen. You will notice something interesting. Once I'm done with this sentence, I have enough syntax to get rid of the error, but the problem is that this is not what I wanted. This does not fix the problem yet. You will see an interesting output in here. False. That's the last part that I got. The reason is because the result of running this function is not matching my expectations. So that's what is giving me a false. What I want to get here is basically a true statement. First problem that I see is the expectations for this function is to be able to take in two inputs, two parameters. I don't have a placeholder for that. Think about it when you're trying to ship something in a box, right? If you don't have the box, you don't have a place to put these values. So let's create those spaces or those boxes so that we can have a number and another number. The other thing that I'm thinking is we can actually cheat a little bit and just write enough code. Let's go back to our diagram where we are just writing enough code to make this test to pass. Right now, I only have one test. I'm expecting a number 2. So one thing that I can do in JavaScript is just return the value that I'm expecting. And guess what? I just passed my test. Is that good enough for you?
No. Because what happens if we do 1 plus 2?
Oh, let's give it a try. So this is the other cool thing about applying TDD. By thinking about the test first, before you do implementation of code, what you're thinking is not only one single test case scenario. I feel like you can start to ask questions like that. What about other cases scenarios, right? Which one you would?
1 plus 2.
1 plus 2. So what will be the expectation for that? Probably number 3, right? And what happens on our test? It seems like we have a lot of mess in here, so a quick way to fix this is clearing the output, make sure that I save this, and let's refresh. Now you will see that the first test is giving me true, so that's still, it's working.
Right.
But the second one is being false, and that is because no matter what I do, this function was created just enough to pass the first test, but not to make this code dynamic. So it might work for me, but it's not gonna work for you.
Mm-mm.
So that means that this function is not good enough, right? So thinking about the diagram, I feel like we can jump into the next stage. We want to refactor, and this is a term that we use in programming to go back to existing code and change it, and most likely with the purpose of making it better, right? So that's what we're saying. How can we improve the code, right? This is good enough code just for one case scenario, but I feel like it's not good enough for the rest of the implementation that I want to get.
Right.
So let's make this better. I know that not every single time is going to be a number 2, so let's make it better. Let's grab those placeholders that we were having, those little boxes that I created as parameters in my function, and then let's do the operation between them. And guess what happens? When I take a look at my results, they're both true now. So this is kind of nice because I'm getting to the point where I can test several cases scenarios. Now these are only 2, so I don't feel comfortable with that anymore. Do you have any more complicated code that I can test here?
So we could just try to get we could try a negative number.
Negative number. I like that one. So I'm just gonna copy and paste this line. I'm getting a little bit uncomfortable with these lines, but we will find better ways to test this. Let's go by order. Let's do a number 3. And then how can we get a number 3? Maybe if you put -1 and 4. -1, +4, that will give me a number 3. And it seems like we got all of them, they are true.
It's good.
It's also getting messy. If you take a look at my screen, I'm getting a bunch of true statements and a bunch of false statements all combined. So I feel like it's getting hard to read. imagine if we continue doing this at the end of this webinar, I feel like we're going to have a bunch of noise.
We won't even know what's going on.
Yeah,
The other thing I was going to say is that all of this code up here, we're starting to have a bunch of code reproduced, and I'm wondering if there's a better way that we can put this together.
Makes sense. So I'm glad that I have a navigator with me, because I was thinking, how can I improve this? Especially because I see a lot of repetition. I want you to pay your whole attention into these 3 lines. It seems like there's a lot of patterns or repetition that we can play together. Let's think about a little bit of what the purpose of this was. It seems like all of them, they were having the intention of printing a value and also do an operation. We learned a little bit of what the function is doing. The reason I put a function in here instead of making this operation every single time is because I do not want to repeat myself and copy and paste the same line. Especially if I'm gonna make changes on this function later on, I feel like this is gonna become harder and harder to maintain when I go back to it and I try to change something. But if I have it in a function, I can call it whenever I want it. That's the first benefit. The second benefit is if there's a change in the logic, it's gonna change once instead of several lines. It's just gonna be a small change. So that makes me think, I feel like it's a good idea for us to do something about the way we're testing our code. So yeah, any guess?
Well, we could write a function that we could pass in our assumption and then the result from running the actual code. What do you think about a function named expected?
Expected.
Or expect.
I feel like expect sounds better, so let's play with that one. Function expect, and then let's think about the parameters. The first thing that we were thinking about is
we need to
the result, right?
Right. What is our expected result?
So expected result is too long, so let's put expected, if that sounds good.
Sounds good to me.
Another parameter that I want to know is, in order for me to be able to compare, is what is the actual result that you get, right? Things that I've seen in other frameworks and in the field is that we call it actual value, right? So let's play with that. We are creating another function that is going to simulate or do the test for us from now on. So let's see how we can improve this. If you think about it, we're kind of doing the cycle again. Right now, we don't have a lot of like red tests failing right now, but I feel like we're still refactoring and improving our code by just following the cycle.
So you would say we're in the 3rd stage right now. All of our tests are passing. We're getting true back for everything, but now we're going to try to make it. We're going to try to make even the way we're doing our testing better.
Exactly. You might think this is kind of silly and unnecessary right now, but for the plans that we have, I feel like this is going to help us a lot. Like, these are not the only tests that we're going to run. So we're going to end up copying and pasting way too much code, if that makes sense. Plus, I feel like it makes more sense. If I invite Dimitri tomorrow to join us and try to contribute to this code, I feel like Dimitri might have a better idea or understanding reading this code and say like, oh, I think I can understand what the intentions behind this code is.
Yeah.
So you definitely want to make sure that your code is self-descriptive and anybody can just pick it up and try to learn from what the intentions were. So we want to be kind to ourselves in the future and kind to the rest of the team that works with us. So I like that. So let's think about this. Let's put this in comments and let's think about how can I improve this?
So what Fernando is saying is we're going to comment out the code temporarily. A comment just with the 2 forward slashes right here, it just means that it's code that is not going to be interpreted anymore. So it's not going to be run anymore.
We can actually check if that's true by pressing clear, and every time that I'm making a change, it should not give me all these true falses anymore.
Right.
The reason is because I want to make sure that I finish this before I get a lot of noise in my console. So one of the things that we wanted to do is to run the brand new function that we have. And the reason I wanted to put it in comments is because I don't want to lose my tests.
Yeah.
So I want to keep it like visible, so that way I can keep following that syntax. So my expected value or my expected result is still 2. And a second parameter is going to be the execution of that functionality, right? So this is going to be 1 and 1. Now, notice that I'm not doing a console log anymore because that's what I'm expecting to do here. Since I noticed that console log was part of the things that I want to do, like print the values. Let me see them, right? So the console log is gonna happen in here. I'm gonna do something interesting for this one. I feel like one of the biggest problems that I had when I was testing this is I just had a bunch of true and falses, and it was hard to follow which one is which. Probably the audience was having the same problem, like try to follow, like, I don't know what's going on in the console, right? So I feel like we can improve this process if we put like a label or something that a human can understand, some pieces of text. So I'm gonna do something interesting in here. I'm gonna put the expected value here that is coming from the boxes, and I'm gonna add the evaluation that I'm expecting from the other side. So what I'm thinking is we're just using double equals to compare values. So I'm gonna start to put the values that I'm expecting or representing those pieces, and then I'm gonna put a comma on my console log so that I can see the actual value. Now what's happening in here, I feel like it's gonna be, I think I'm lost in this one. Just the console log and the actual value. So it's gonna be the expected value.
See, already doing it. Expected equals actual.
This is the one in the parameters, and then I will do the actual. Now let's just stop here a moment because I feel like this is gonna get confusing. The first part of this function, it's an actual text that you're gonna see down below in here. So what I'm trying to do here is just make a visual representation of what's going on with the pieces of data. And on the other side, I'm actually executing code. This is actually code being executed by the computer, processed, and then giving me a result. So think about this first part as a label. And that's what I wanted to get, because I feel like the audience might be confused about like what this true belongs to or what is making a reference to. We didn't have the opportunity to have this in here. We could have put it in there, but I feel like it will get it even more difficult to read.
Right. And the reason why we create functions like this is so that now we can go back and decide, oh, for every test, I want to print out a label that tells us what was going on, and we don't have to actually do this in every line of code from before. So it's very good, Fernando.
Makes sense.
Yeah.
It's also like to label my things so that way I can see which one's which, right? So yeah, I think it's working for the first one. So let's give it a try with the next ones. So now if you notice, it kind of got shorter. So now I can test these couple of things. So let's transfer these values from here to here so that we can test them. The other one was a number 3. So let's make it better. Let's test the number 4. So -1 with a 5. And it seems like we're not gonna use this anymore. Let me clear my console so that way it's clear to everybody once I delete this. And let's see what we get. 2 equals to 2, that is true. 3 equals to 3 is true, and 4 is true. Where those values are coming from? Remember that our expected value is the results that I'm expecting, and this is the addition between those two numbers. So I think it's easier to read. I feel like people can pick it up from here and accommodate those pieces. How you feel about it?
I think so. But so far we've only tested the happy path.
That is true.
We've not done anything crazy yet. And this is where it really starts to shine. You start to think about, how can I break my code? And one of them is, what if we, let me type a little bit. I haven't typed it all.
Yeah. So let's switch roles, and you can grab it. We're gonna switch roles. Now I'm gonna be the navigator. He's gonna be the driver, and now he's gonna be focusing on the not so happy path, right?
Right. So we're gonna try a couple of things and see if we're still going to be able to pass all of our tests. So let's.
What do you have in mind?
Let's try expect. What happens if instead of just passing numbers in, we start passing in strings? So now I'm passing in the number 1, and I'm passing in a text representation of the number 3. And as you can see, things have gotten a little crazy down here. It's saying 4 equals 13. Well, that's definitely false, and it's not working the way that we expect anymore. And it's really good that we have this set of tests, because now I can sit and think about, well, how do I handle it? Do I want to not allow them to pass a string in, or do we want to allow them to pass a string in? What do you think?
I feel like as a human being, they might look like numbers just to me, but it doesn't to the computer. So I feel like we have to be more explicit on what we meant, right? The reasons we want to be considerate about, like, maybe they try to fix what the user tried to communicate in here is, think about this information can come from a form. I feel like everybody has experience filling forms and sending information through the internet. Like when you log into your favorite app or something like that, you don't know, you cannot know or predict what the user is gonna type. So I think it's better for us to be prepared for that. And something weird, if you save and refresh, so we can see the output again, something weird that JavaScript does is that if you put a piece of text and refresh so that we can see the output, if you put a number and a number representation as a string, if you take a look at the output, instead of making an addition between those two numbers, it just put them next to each other.
Yeah, it just basically treated them as 2 strings.
Yeah. So now it's like a bigger piece of text instead of 2 numbers being sum or being mathematical, if that makes sense.
So the major question that we've got right now then, do we want to allow them to pass us a number and then handle the fact that a number was passed to us?
I feel like we should be prepared for either case. So I feel like there's a way to improve this. So let's go back to the diagram so that way we can show them where we are.
Sure.
I feel like we are in the red zone, right? Because we have a failing test. We are not prepared to receive numbers as pieces of text. So I feel like we should be able to write a test. We already did that. The test fails. Can you point it out to them?
Right. So the test is currently failing as of right now. Now we need to go through and write code to make that test pass.
So let's try our best to go to the green zone.
So I happen to know that in JavaScript there is a function that will allow us to take a string and convert it to a number. It is called parse int. Now I don't want to go too far deep into what that means, but at a 30,000 foot level, what it means is we are going to take and parse or convert a string representation of a number into a number. So let's give that a shot. Let's see what that looks like.
That sounds powerful.
It's called parse int, and I'm going to pass in the first number, and then I'm also going to do it.
So just to be sure, you're going to do it on both sides.
On both sides.
Both
now,
numbers.
To be really specific here, what happens is if you pass in an actual number to parse int, it just gives you the number back. But then if you pass a string into parse int, it converts that string, it converts that text representation of a number into a actual number. All right, so let's see. Did we actually pass everything now?
Good news is that the latest output from the console is actually giving us what we wanted.
Sweet.
A small suggestion that I will make is let's increase the value so that way we can have an easy way to follow up. So can we increase the result to 5?
Oh, you want to, of the previous line?
Yeah.
So we want to change the test.
Yes.
Okay.
So that we have like 2, 3, 4, 5, and it's easy for our audience to follow up.
All right, so let's just do this.
So the only thing that we're changing here are the values, so that way you can see that no matter what the values are, the piece of software that we're building now is even more bulletproof to handle edge case scenarios, right?
Right, and this is something that can happen, especially on the web, where most of the web works based on text representations and not actual numbers.
Now, I'm not really convinced yet, so one thing that I would suggest is to add, what about 2 numbers that are both strings? And maybe we can expect that number 6. So that way we can go in order.
Let's do that. So let's try 6, and then we're going to, the way that we'll do this is we'll say 3 plus 3.
That makes sense. One thing that we forgot to mention is like for the ones who are new to JavaScript, putting the double quotes between the number That's what it makes a difference between a number being a piece of text or a number being a number without it.
Right. So this right here, the 1 on this line right here that I'm highlighting, that is an actual number. And then over here, it is what we call a string, and that is a text representation of the number. And anything in that string is going to be considered text. Anything between the double quotes will be considered text.
Exactly. So the first test is actually more risky because we're combining both, right? A number with the string. Now I was wondering what happens if we put a number that's a string and another number that's a string. So let's see if this works. Oh, you already have it.
Yes, I've already. It did work.
Computers are really fast. We can actually see that 6 is equals to 6 because it was successful. My expectation, or your expectation, our expectation was 6, and the numbers that we introduced was 2 threes with the strings.
And it worked.
One last thing. What does the order have something to do with it?
So let's try that.
What if we flip now a string first and then a normal number? So
good.
Would you mind if we test 7? So let's do a string number, and then the second one could be just a number.
And it looks like it works.
Nice. So if you think about it, we did a lot of testing here. Like we just threw a little bit of like a lot of crazy ideas in here. We were thinking about it. The cool thing about, and one of the things that I appreciate the most to work with somebody in pair programming mode is that we can have this conversation, right? And more like a task or like feeling like it's your job. It's more about like having a conversation with another human being.
Right.
And then solving problems, which is my favorite thing.
Yeah. and the other part about this too is that as we go through this and create, one of the things I want you to notice is that all of our prior tests keep continuing to pass. But if we had done something that introduced a problem in one of our other test cases, it would have come back and let us know immediately that one of our other test cases was breaking. Yeah. But luckily today, everything that we're doing seems to be passing.
Yeah, either we're doing a great job or we are not writing enough tests.
That's right. Oh, there's always more tests.
Oh yeah.
There's always more.
We definitely, in the interest of our audience, we don't want to like confuse you way too much. So we're gonna keep it simple. I hope that this feels simple enough. Also let us know in the comments. But I feel like this is a good time to switch roles because I have another crazy idea.
All right, man, go for it.
So the next idea that I have is, we did simple math, right? I want to experiment a little bit with multiplications. I feel like subtraction was in my mind, but I feel like it looks almost the same as the add function. So I feel like we can think about something more interesting. So let's put some comments in here. What if we do squares? A square of a number in math is basically the same number multiplied by itself, right?
Right.
So let's keep it simple. What about the square of 4? So if I want to know like what the square of 4 is, I'm expecting that to be 16. 4 times 4.
4 times 4 is 16.
So
yes.
16. So I think we can build a function that does this for us. How do you feel about it?
Absolutely.
Excited?
Yes.
Cool. So just to clarify, we went through this process with the last one, and I feel like we are done. So we're going to move on to the next one.
But we're back in the red. We're going to write a test.
Now that I have a new task, I feel like I'm back to the beginning, right? So
yep.
That's what I have. You start from here.
Right.
So I have an idea. I do not have a test yet. So I feel like we should start from that. Now that I have a function to test stuff, these functions, I feel like I should start from that. I have better structure now, so I feel more comfortable with this. So based on my comments and my idea, I already know the result. My expectation is 16, so I'm going to put that on my left side, right?
Right.
Now I feel like super powerful because I'm running my own function. Like I just built something by myself. So I feel like kind of cool right now.
That's the cool thing about programming, y'all, is that you get, we start off with an idea and we can just create something out of thin air. It's
Makes
really
sense.
cool.
Yeah. I would like to do a square, but question, do you feel like most of the people would know what this means? It's Q for a square?
Why don't we just type out the whole word, square?
Fine.
I know.
It's okay. So we can do a square, and then from what I see here, what I was thinking is we just need one parameter, right? And I already know what the parameter is. So I'm gonna have the number 4 here. Now, you will notice in my console that I have the same problem that I used to have when I was trying to add the function add in the first place. So if I think about it, going back to our amazing curriculum, we are still in the red zone. Why is that? Because the test fails, but for the wrong reasons. Right now, the test doesn't fail because it doesn't match the expectations. It's because we have an error, right? Remember, in programming, most of the times the computer is going to try to communicate what the problem is. So reading the error is going to be a great idea. It seems like they don't see a reference. Basically, the square is not defined. So that means that the function that I'm trying to use does not exist.
So we need to write one.
Let's write one. I feel like it will be nice if we go in order.
Sure.
So the syntax for that is function, the name of the function, and the curly braces. We were talking about having a parameter. So this is a number, any number. This is the placeholder that is going to hold that value. And you start to see that the test is already running. I have 16 equals to undefined. What is that?
Well, it just means that we have a variable that has no value, or we have a parameter that has no value assigned to it.
Exactly.
So it doesn't know what it is.
So right now, this line is being executed. The square is executed with the number 4. But tell me, are we doing anything with the 4?
No.
Not yet.
So we're not returning anything, and that's why it's undefined at this point.
The reason we use the return keyword is because we want to process the information and then take it back to the whoever called it, right? It's like you delegating tasks to me, and then I will do the task, and then I will deliver results to you.
Right.
Does that make sense? So let's think about this. I feel like the math behind this is simple. Whatever number you gave me, well, let's do something interesting. Let's go back to our cycle. Write enough code to make it pass.
Oh, okay.
All right.
Let's do that.
So what is enough code? What was my test? 16.
You can just return 16 back.
I will return 16. And
it passes.
I'm done with my assessment, so I got a 100.
But what happens if we send in another number? So let's say let's send in 5. We should get 25.
That was not in the list of requirements.
Well, now it is.
So most likely you want to cover every single case scenario that you have, right? So let me type this again so that we can see it slowly, right? Remember that we have a specific function that we create ourselves to test code. Now let's run another case. Which one you were thinking about? Number, 5. You know what? I want to go crazy. Now I'm going to be the negative Nelly.
Oh. So what are we going to do?
What about the 0? What is the square of a 0?
Well, what is 0 times anything?
0.
Okay, let's just say 0.
My expectation is 0 square, and my parameter is going to be 0. So we have a problem. 0 equals to 16. That is false. Because actually this false is true, right? Like
it is definitely false.
Yeah, it's definitely false. So what happened? I grew up enough code to pass the test, but now that I have more tests, this code passes the test, just the first one. But I feel like now we're in the blue zone, where we need to refactor and we need to improve this code. The reason is because this code is not good enough, right? You will be surprised how many people I've seen trying to cheat the tests.
Okay.
So let's do it the right way. I feel like the better implementation of this function is number times number. It's the number multiplied by itself to get a square.
And so this little asterisk in the middle is the multiplication operator in JavaScript.
Correct. Most likely as humans we will do this, but that is not good syntax. You will get an interesting error here, right? So yeah, the operator for multiplication in JavaScript is this small star sign. And our test is passing. We didn't lose the opportunity to pass the first test,
right?
And now we have the opportunity to test something else, right? So let's keep playing with this. I feel like I'm still not. I don't trust this function.
Maybe let's try a negative number.
Negative number. Let's do -5. So let's think about this. Times 5. How much is it? 25.
Yes.
But if it's negative, negative number times negative number, that's going to make it positive, right?
Right.
Based on basic math. So I feel like my expectations, if I'm using 5, is no -5, is that I'm going to get a positive number in return and also the multiplication of that.
And that's true.
Interesting. So that worked. Cool.
You want me to blow it up?
Let's break it.
Pass a string in there.
Let's
see if a string will work.
You're testing my nerves. So
I basically threw that one new in there, Adam. We don't know what this is going to do. So welcome to the testing, the testing episode.
One of the tests that we can run is 100. No, 10. Let's do 10.
Do 10.
What would be the expectation? 10 by 10
would be 100.
So let's give it a try. And
you know what? It handled it.
This is so weird, right? I'm testing 100. I'm getting 100. And then it's working. How's that possible? The multiplication operator, it's doing something automatically for us.
Yeah, so the multiplication operator is doing something very strange. It is actually converting that string into a number, which we don't want to rely on that. So I would say that what I would do is put a parse int around that at the bottom.
That sounds like a great idea, because I feel like we are noticing something right now between us.
Right.
But if there's a third member and she is reading the code and she's expecting this to be numbers, and for some reason this actually getting some strings, I feel like it might be confusing for this person.
Right.
Right? This programmer is going to be like, oh, that doesn't make any sense. So one thing that it could cause some noise in the process is you're being curious about why things work and why things doesn't work, which is also a good thing. So I feel like this programmer might end up spending more time thinking how this is working and trying to understand the language instead of focusing on what the task is.
Right.
I feel like when we say parse ends, the intentions are clear that we were definitely expecting this to be numbers.
Or we're definitely going to make sure that it is a number. So it's an explicit way of saying this. And one of the things that I would want to communicate as far as how we write code, computers don't really care how the code looks as long as it compiles, as long as it's correct syntax. But the reason that we write the code the way that we do is to impart intention to other human beings. That's a very important thing to think about when we write code.
Yeah. Especially JavaScript is a language that is really forgiving, and in combination with the browser, a browser like Chrome, Firefox, Internet Explorer, like most of the time they're gonna try to fix your code, even though if it has small mistakes, you're missing some syntax or something, they're super forgiving. There's languages that are not, like Java, which I love because there's more structure and rules to follow. So there's less space for us to think about like, I can do whatever I want and not finish my sentences or not put in the right syntax or something like that. And that could cause troubles later on, or you getting used to not the right way to code, I guess.
Right.
Like the best way to code. So I feel like we have 4 tests for this new functionality. I feel really good about it.
I think we're good.
Now, something that I've seen in the field is, and we have done it already, is creating functions, creating pieces of code that we can use and reuse. Right? So I want to take it to the next level. What if I do a sum of squares? That way we can play with the function that we just created with adding 2 numbers and the square of a number, so we can play with them. What if we add 2 squares? Plus, we already have the results, so I feel like we can play with this really fast. So a quick test that is going through my head is maybe we can do a sum of 16 and 0, but by executing the function, in 25 and 100, but by executing the functions. So it seems like a great place to switch now.
Yeah, let's do it.
So I'm gonna stop being the driver. I'm gonna be back into a navigator. I guess you can use this also as well if you feel more comfortable like that.
We're good.
And let's start to think about this. I think this is gonna be easier to test. Maybe we're gonna skip maybe a step in the process because we have a lot to play in our plate already.
Right.
That we can think in the positive way of thinking.
So when we say sum of squares, all it means is that we're just adding the values of the squares
Yeah, let's
together.
highlight it. Can you highlight this line so that way they can see what we're talking about?
Right.
So basically just sum the result of executing this highlighted code.
Right. And so I think the first thing that we need to do, like we've been talking about before, we need to write a test first that's going to fail. So what if we say we're going to add the sum of 16 of 4, square of 4 and square of 0 together, which will come out to, I'm expecting a 16 from this when we run it. So let's just call this sum of
squares. We have a small typo there. It might sound annoying, but the navigator job is also to spot.
That's what they're supposed to do. A navigator is supposed to help you with that kind of stuff.
Yeah,
so
and it's not it's not about like me pointing out errors and just pointing fingers. It's more about like we're working on this together, and I feel like it's easier to fix errors on the fly than going back and play with this, if that makes sense.
Right. And so all we're going to do here is pass in the 4, which would give us a 16 back, and a 0, which will give us a 0 back, and we're expecting a 16. But as we've said before, JavaScript is coming down here and saying, hey,
function does not exist.
This doesn't exist yet. So the first thing that we need to do is create that. So let's come down to here and create our function, sum of squares.
And I believe we need 2 placeholders, right? Because you have 2 numbers.
Right. So we will just call that number 1 and number 2.
Makes sense. Doesn't matter what name we put in there.
No, in this declaration, it's just the container, the name of the container that we're storing the value in. This could literally be named anything. We can call it num1, num2, number 1, number 2, anything you can think of, we can call it that. But we want to call it something that will mean something to us within the function.
So I can put Spanish in there.
You could, but it wouldn't mean much to me if you did.
Yeah. Okay.
All right. So here's the interesting thing right now. So right now we have a failing test. It's coming back undefined because we're not returning anything as of right now. But if I type in, let's see, let's use the same methodology that we've used before. We're expecting 16. So I'm just going to be smart and return 16.
That's a little bit cheating.
And it's true now.
So we passed our test.
We did pass our test.
We can go home.
Well, but we need to write some more tests. So what are you thinking?
I would like to see some negatives. So let's try -5. You know what? I want to break the world. So -5 in a number that is a string. So let's try -5 and 3. So let's think about this. The squares are going to be, if -5 is, can you highlight the line so we can point people at the right place? We already know the results between -5, which is 25.
Right.
What if we test the next one that is a string? So let's test the last 2, right? So the sum of the results of that last 2
That'd be 125.
is 125.
So let's try that.
Let's do our expectation in there. So I definitely have to do this by hand, right? Like we did the sum in our head because we already know the results.
Right.
And we trust the results because we wrote tests. So that's what I rely on them, right? This would not be a good idea if there was not tests at all. So we are going to do sum of squares and put the inputs with -5 and 10 has a string. So this is getting crazy. Negative numbers represented as a string. So let's see what happens.
So right now it's false. As you can see down here, it is definitely false because the only thing that we're returning is 16. This is what we call hard coding. We've hard coded a response. It's not dynamic, but we need to actually make this dynamic. So the next thing that we can do, and here's what's cool about having code that we've already tested, there is already a square function. So all I would have to do this properly is just type in square num1 plus square Number two.
I have an interesting idea. Why will we have to do this operation again? If you're using the operator, can you highlight it so people can see it?
Oh yeah. Okay, so first of all, before you go there, our test passed. So what Fernando's about to do is he's about to recommend a refactoring.
Ooh,
The behavior is going to stay the
let's
same.
show them where we are.
So we're green.
Yeah.
But now we're sitting over here in blue. Fernando just said, as your navigator, I just figured out something we could do better, Douglas.
Yeah.
Why don't we use some other code that we've got?
And I know that it might seem unnecessary, but I feel like the sum function has been tested so well that I rather rely on that one instead of creating your own implementation of the process.
Sure.
I'd rather keep using a function that we built, we believe in because we tested it. So the only thing that you will change, you can keep it. Let's make it simple. Just delete the operator with the plus, put a comma instead, and then let's wrap it up into the other function, which is add, comma, and then another value.
So let's see if our tests still pass even after doing that. And yes, so our tests still pass. And the cool thing about using this is that you've noticed that I'm no longer doing a parse int anymore in any of this.
Oh,
so because my other functions are handling converting the text representation to a number, I didn't worry about it in here. So that's something that I got for free by reusing functionality that we've already tested, and we know that works based on these prior tests.
Makes sense. I like it.
So I think we've kind of done we've done some good stuff with this math.
I like it. We can definitely go home after this, and most importantly, I can go sleep because I'm not gonna be thinking about, I wonder if I can break it this way or the other one. Like, this makes me feel more comfortable about the code that we just wrote.
Right.
Especially working with someone so talented.
Thank you. So like what?
Yeah. So this is kind of like all the examples that we wanted to show you. Again, we apologize for any confusion about the syntax. It's not the purpose of this webinar to show you how to learn JavaScript. What I wanted to show you, or we wanted to show you this time, was how being a developer looked like on 2020, right?
Right.
Applying the latest version of collaborating, testing your code before you push it to somewhere like in production, how it goes through a process. It's not about like, I have an idea, I put it into code and go and fly away, right? Like, you need to be able to test it to prove that it works and think about all the 20 ways it could break, so that way you can trust your code. I want everybody in our audience to imagine how would you feel if you make a transfer between bank accounts and it doesn't work the way you expected, right? Like all of those delicate transactions that happens between money or medical fields and stuff like that. Think about the NASA, like they need to have a really good trust on what the scripts are running, the programs that are
life and death code.
Exactly. Like there's a lot of consequences that can come and make life even more difficult and easier, which is the purpose of writing technology, to make your life easier if you don't test your code, right? So the purpose for this whole webinar was to show you how we can test our code, how we do it nowadays. I can tell you that testing code, especially if you Google TDD right now, there's going to be a bunch of libraries, languages, frameworks that is going to handle it in a better way. But what we wanted to show you today was how we do it, how we think about it, how the process might look like. Because in reality, we don't do this by bare hands and just like create your own testing frameworks or your own testing functions. There's going to be a lot of utilities that you can grab from somebody else that can help you to make this process even easier, faster, and more reliable. Because testing math right now, it looks simple, but there's more complicated problems that needs more complicated tools, right? So you're gonna find more interesting ways to test your code. And the good news is that we do this in CodeUp, so we definitely show you how you test your code in the front end using JavaScript. We just added a new module in Java, so we show you how to test your code in Java using JUnit, which is another framework. And all the way to the framework we teach is a Spring Boot, which allows you to create web applications. Yeah, just like the ones you use in your phone, in your computer, in your tablet. and we can also test those. So we definitely want our students to get like the full picture of what they might expect in the real world, right? Because when you read a book about it, and or when you go through some courses online, they don't cover like the most in-field techniques that you might find. So once you get hired, that's when you face the wall and it's like, whoa, I never thought about this. I never saw this before. And that's still gonna happen, right? But you want to be better prepared for that, especially for something that is gonna be beneficial for everybody, your team, yourself, and the software that you will write.
And so we also, the code pen that you looked at while we were coding, we have a code pen that we're going to send out that has got all of what we worked on in there. So you can click on that link, you'll see everything that we talked about. At the bottom, we give you a few more extra resources on just on pair programming, and we send a link. We actually created a HTML and CSS Learn to Code virtual workshop so that you can take a look at that. And if you are interested in joining us, that we stuck a link into our apply link, so you can reach out to our admissions team, and we can get that process started. And what I want to do right now is open the floor up to any questions that you might have from what we've gone over tonight.
It might be easier if you just type your questions if you have any, so we can see it in here and everybody can see it on the audience if you want to type something on the chat. But yeah, that was basically the examples that we wanted to show you, and the demonstration of how writing code with a team might look like. Obviously, this was a small team.
Right.
Pair programming works with 2 people, but sometimes when we have a bigger team, we use more complicated tools, but more robust tools as well. One of the ones that we like is Git. So we can do like collaboration between teams and stuff like that.
So Tyler has asked us, is being paired a common thing for a junior dev starting off?
Can I answer this one?
Go for it.
Well, I feel like we can have 2 different answers, right? It definitely depends on the environment and the company that you are going to work for. If you ask me personally, I feel like it's the best way to be a thing for junior developer. Why is that? I feel like a junior can learn even faster about the architecture, the technology, and the tools that the company use if they pair with a junior with a senior, or even a mid-level developer.
Right.
Like pair programming is like the best way to also put people up to speed, right? Like this is your first day, your first week. Let's do pair programming so that way you can get used to the tools. I can explain you what's going on and also give you the opportunity to write the code, right? Because think about this, programming doesn't get any better if you're just watching someone, if you're just watching videos. It's more about like working out, like for more videos that I see or people exercising, I'm gonna lose weight. I'm not gonna lose weight, right? So if you're only watching videos but not actually coding, if you are just being next to someone that is coding, you're not going to get the learning experience if you don't do it yourself. So I feel like pair programming for a junior developer should be highly encouraged in any company.
I've seen it work both ways though. So in some companies, I just got thrown off into the code on my own, and that wasn't as much of a success story. I did eventually figure it out, but there have been other companies where I've worked and we paired together, and even as a senior level developer, it actually is good to put 2 people together thinking through issues in a new code base to definitely give them an idea of where things are. So and any company that I've talked to about that they've said they wanted to hire juniors, I've always said you need to be sure that you're going to put a senior with them for a little bit to get them well acclimated to the code base.
Yeah, it's definitely the best way to get people up to speed.
Thank you for that question, Tyler.
Any other questions? You can just type it up in the chat. I think it will be easier.
So I think while we're waiting, yeah, like I said before, I have actually in the past worked in a pair programming a company where no code was allowed to go to production without a pair of developers working on it. And it actually was a really good workflow, because just like today that you saw, we didn't stop writing code. Like someone might get tired and that would you know, that they'd stop and go surf on CNN or whatever. But this allows us to keep going. Even if someone is tired of typing, they can become the navigator and the person doing the driving. It just changes what you're doing and really increases productivity. Now, go ahead. We have a new question.
Just a final thought. We didn't take any breaks, but we were trying to speed this demonstration, right?
Right.
But don't think about like this whole day is gonna be like just switching back and forth. And the reason we're switching is not a reason for the other person to take a break, to be distracted, or something like that.
No, we're still very engaged during the whole thing.
What's going on, but taking breaks for both of them at the same time is highly encouraged, right? Like taking breaks once in a while. Now, somebody's asking about if we include learning C++. So the short answer is no, but our course focus on learning programming languages. So we're gonna teach you how to learn programming languages using JavaScript, HTML and CSS,
Java.
jQuery, and Java, and frameworks that include Java, some libraries. So we do not teach C++, but we're gonna give you enough tools for you to learn the next language. We do this because most likely when a student gets hired, they don't get to choose the language, but they are in this learning mode that it's super helpful for them to just get up to speed with whatever they are.
Once you learn your first language, it becomes a lot easier to learn more languages. And what we concentrate on are the fundamentals. So we teach you how to create a full stack application. We teach you all the skills you need. But once you go through the program, you can go pick up anything else at the point when you're done.
Makes sense, yeah.
Yes.
The next question is, does testing and breaking code help with troubleshooting skills as well? The answer is yes. Because if you think about it, we were kind of finding step by step and putting this big problem and chop it out into smaller pieces and think about all the things that go wrong. So testing actually improves your skill of like troubleshooting, finding problems, finding solutions, and smaller pieces, right? And you can even apply this to your life, you know, like you have this big life problem. So you start to say, okay, I don't even know where to start. So let's chop it into smaller pieces and then solve micro tasks so that we can get to the final task and resolve this goal.
Yeah, I definitely agree with that. It does, test-driven development does help with troubleshooting, not just at that point, but if you ever do something that breaks your prior tests and you have a good set of tests around the code, you can actually see where the code starts to break down. So it really does help with troubleshooting and going in and figuring out what went wrong.
Blanca's asking an interesting question. Will you consider yourself fluent in all coding languages after this 20-week program? Will this allow you to build apps or only websites? And what is considered full stack? So there's 3 questions. So let's just start with the first one, right? Big problems. Let's chop it onto smaller pieces.
Let's do it.
The first one, would you consider yourself fluent in all coding languages? I do not know any human that is fluent in all coding languages.
Right.
I don't think that is possible. So that's what I was saying. The main focus on CodeUp and any software developer, I feel like should be focused on become a better problem solver.
Yes.
And as Douglas was saying, the second language, the third language is gonna become easier because you're gonna start to recognize patterns, syntax, if statements, for loops, like they're all gonna look similar in different languages, but there's no way you can learn every single language in your whole life. Even like, just to answer like the 20-week, like after the program, nobody knows every single language. After a lifetime span from a human, I don't feel like anybody's gonna learn all coding languages.
And you won't really need to learn all of the coding languages because it's basically how do we deliver value to the people that have hired us to write the code. And most of the time when you go into a shop or into a place where they hire you to code, they have a very specific what we call stack, which is just basically the technologies that they use. And so I think the third question was, what is considered full stack?
So what we consider a full stack, when you see that in a job application or something, they're looking for a developer that can handle the back end and the front end. The front end involves technologies like the ones that we touched today, like JavaScript. We didn't see any HTML and CSS, but luckily you will find a link in that resource that we send you with a video with our Learn to Code HTML and CSS part 1, if you want to be curious about it. So full stack is that you don't have any problems with switching back and forth between programming languages and technologies that touches the way that websites or the web looks like, and the backend is more about like how the web works behind the scenes. Think about the engine, the procedures that happen when you submit a payment, the verification on the other side, the verification of or sending an email or something like that. That is what the backend does, if that makes sense.
Right.
Mm-hmm.
So, yeah, and I completely agree with that. I think that it's fair to break that down. It just means that you have the ability to write code that, like what we were writing tonight, the HTML, CSS, and JavaScript, and then also like the back end, which we teach Java and MySQL for the back end. The next question that we've got is from Maureen, which she asks, for the 20-week program, is it available remotely? And I would say, well, I'm going to say the answer is no. It is not available remotely, because what we have found is that it is better during that 20 weeks to do a full immersion. This is the only way that it works well, is to do a full immersion 9 to 5 day for 20 weeks. And that really gets you into the mode of programming, because it's really about doing or writing code. That's how you learn. And so that's why we've never really gone into doing a remote program or a part-time program like some of the other schools have done.
Exactly.
And then also, what is your perspective on the difference between data science field versus the software developer field with regards to coding? Now, this is a really good question. We probably both should answer.
Yeah, so since you just gave an answer, let me give it a shot. I'm not a big, I'm not like I don't have a lot of knowledge of what data science is going to look like in the field, but I've seen my coworkers working on that department. And it seems like data science is more about like learning tools good enough for you to use it to produce results from data sets or predict models or something like that. So I can definitely say that there's less coding on data science. It is more about like using tools that use code to predict or get those results or predict those models, versus software. And I don't even like to say versus, like I think they're two different fields.
Right.
They're not competing each other. It's more about like they actually support each other.
Exactly.
Right? So they're kind of like I wouldn't say that there's going to be a professional that can do both. I feel like they're two different sciences. And software developer is kind of like building the tools. If I can put it in a small example, maybe a software developer can develop a tool from scratch that can help a data scientist to do their job.
Right.
And the data scientist can give us more information about the data that a software developer is producing or getting from somewhere that a software developer wouldn't be able to like say something about the data. Basically, it's like making sense of what all this data that I got from a database or something, because I can get you the data, but I don't know what that means, if that makes sense.
I fully agree with that. So they are two different fields, and they actually require majorly different skill sets in order to move forward with it. Does that answer your question, Maureen?
Well, she answers. The next one is an interesting one. Do I need to know? Oh, sorry.
Oh no, go ahead. I'll wait.
All right, you can type it up either way. Do you need to know any binary or Xcode as a web developer? You don't need to, but you're gonna see it, right? Especially Xcode with CSS colors or something like that. Like you're gonna see hexadecimals all over the place. The most common use to see it on the front end is by colors. Like every single color has an Xcode that you can play with it. You don't have to understand the science behind that. It's more about like understanding how it works a little bit on the surface.
Yes.
And how to use it and apply it to the code or the tool that you want to develop. But it's not a requirement, but you're definitely going to see it. Binary is a little bit more deeper into what computer science is going to look like. So I think it's the same. Like I feel like you can understand it in a simple way, but you don't really have to know what binary code. You're not going to be finding yourself like translating numbers into binary that often. Like maybe it will happen once in your lifetime, or maybe twice.
Yeah. So after 18 years of writing code, I will tell you that I have never used binary directly, and other than colors in CSS.
Yeah.
I've not done anything with hex other than specifying colors in on the front end. And
Yeah.
so don't let that put you off. There will be points in your career as you go down a software development path
Yeah.
where you'll say, oh, I understand the binary. I understand why I might want to know what binary is about, because it's how we store data on a computer. It is all stored in binary, but it is not something that you need to know in order to get started in software development, and something you won't even really, I think, for a very long time to come after you become a junior, wouldn't even worry about binary at all.
Yeah, one last thought on that one is I just want to be super clear, like, as a software developer, you don't have to know everything, right? Most of those things, like, as an example, my first job was in a video game company, and I ended up developing an accounting system. So nobody will tell me, like, as a developer, you need to know all these accounting terms, right?
Right.
So I ended up learning a little bit of the accounting. I tell you that example because I feel like most of the things that might be necessary for the job, you're gonna need it when it's needed. Like whenever you are developing an application that is in certain field, that X requirement or that binary requirement or something new that you never heard of is gonna be useful when the time is right. Like as software developers, most of the time you are gonna face a lot of things that you don't know, but the good news is that you're gonna become a better problem solver. So you're gonna know where to start to solve a problem, but there's no way we can know everything.
Cool.
Yeah.
So it is 8:08. We have gone a little over our time. If as long as we've got questions, we can stick around and answer questions for a little while longer. But
maybe another 10 minutes.
Yeah. So let's give it another 10 minutes or so, and we like I said before, we're happy to stick around and answer some questions.
Yeah, unless Demetrius want to jump in or something.
I don't think.
Hey guys, so I just wanted to, I guess, get quick clarification, and you guys did great explaining it. It did help. I think when I noticed that you guys did data science also, and that piqued my interest because I work with a lot of data when working with the ED docs. So I just wanted to know, is there any type of coding involved when it comes to data science? That's kind of, I know software developers is very heavy with coding, but data science, I wasn't sure, probably SQL, but not sure if it's like heavy, just like the software developers.
So just a short answer. Again, I feel like it's going to be more focused on the tools, right? Like think about SQL as a language.
Right.
There's going to be a tool to get you that piece of information and the data in the right way.
Right.
And you're going to have to use the terminal a lot, right?
Okay.
Like most of these tools in the computer are going to be installed in the terminal. You probably heard somewhere Python involved in data science, right?
Yes.
So Python is kind of like the main language. I think I heard R as another language.
Yes.
But they don't develop applications on those languages. It's more about like running scripts and existing tools or applications in the terminal using those programming languages. The one that you get more like hands-on or like getting your hands dirty might be SQL. Like you definitely have to like get comfortable with the language and throw in a little bit of queries, so that way you can get the right information from the right place.
Okay.
But definitely, I feel like if you want to be a data scientist, the terminal and Python and these kind of languages that run, they're going to be your best friends. But it's not expected for you to build your own tools, if that makes sense.
You won't have to build web applications. So I've actually seen some of the final projects from our data science team, and
we might have videos.
And there may be videos out there. We'll have to find them, but most of the time what they're doing is presenting data sets and saying that these are our findings. A very sciencey kind of of thing. But in order to get the results, you do have to run. I mean, there is some scripting involved, but it's not like where we teach, in the web development side, and we're both web development instructors. Where we have to do the, build a web page, build a database, build, it really is strictly about getting these huge data sets and doing some work on those data sets and coming up with
logical findings on it. Yeah.
Right.
I feel like the few places that as a software developer and a data scientist combined is SQL.
Right.
Like we both work on that.
Cool. Thank you guys.
You're welcome. Anything else? I see a lot of thank you, so we appreciate it. Thank you for
coming.
spending our time with us.
You could have done anything else on your Wednesday night during your free time, and you chose to come listen to us talk about test-driven development and pair programming. So we're happy that y'all came.
Really hope that this was helpful. Gives you an insight. I think we are ready to close out then.
Yeah, I don't.
You're gonna expect an email from us. I really hope that you got the link. Either way, we're gonna put the link of the resource, the final result that we got. If you want to play with it, if you feel like brave enough to change the code, just make your own copy and run it and give it a try. Like one of the things that I like to see in my students is they actually start to lose they're kind of start afraid of the code because they might think that they might break something. But eventually they realize like nothing breaks when you're testing this in your computer, right? So I want everybody to feel in a safe place. This is a friendly place where you can fail, and failure is kind of part of the procedure. Like this is what I wanted to transmit that to you. Like we were making a lot of failures.
I even spelled square wrong. I mean that's it's one of the things in programming. You have to get used to being in a failure state for a lot of the time, and then always trying to get back to everything works the way that we think it's supposed to work. So it's
embrace failure is part of the process. This is how we learn. Think about it when we learned to bike for the first time. Think about it when we try to walk for the first time
or drive.
Well, that's more fail, but
you can't fail while trying to learn to drive. All of it. You always have this feeling of when you first get started with it, I don't know what's going on, what is happening here, and you have like everything. But as you do this for a while, and just from both of us, we remember what it was like to get started. Yeah, definitely.
Yes.
We remember what it was like to get started, and it's just as you get started writing code, it's everything like what is going on, and then as you do this for a while and get used to it, that's why the full immersion 20-week program really works well for this, because you start getting used to not only feeling like in that state of what's going on, but then also in the state of succeeding and getting to where things are starting to work, and it's getting easier and easier as time goes on.
Sounds good. Well, thank you. We appreciate your time, and I guess there's going to be an email coming soon with more resources. We're going to include this link, and make sure you click on those. I feel like they're going to be interesting reads, and feel afraid to copy that code, play with it if you feel brave enough.
All right. Thanks, y'all.
Till the next time.